Alright, in this video we are going to do a little bit of review with a lot of things we've done with right triangles. Alright, so the first big thing we did with right triangles was Pythagorean theorem. Alright, so Pythagorean theorem we said was a squared plus b squared equals c squared. Alright, and remember, a and b are the legs and c is the hypotenuse. Okay, so what that means, okay, the two legs are the two sides that make up the right angle. So these would be the legs in this right triangle. Okay, these would be the legs, and then the hypotenuse, which is the side that doesn't make up the right angle, this would be C. Right? So I guess we can color code here. A and B are the two legs. So here, it doesn't matter which one's which between A and B. Okay, but these would be A and B because they make up the right angle, and then this would be C. So my setup here, if I'm doing A squared plus B squared equals C squared, is going to be 9 squared plus 17 squared equals x squared. So now, we just want to square both of these values. So 9 squared is 81, 17 squared is 289, and that'll equal x squared. Add these together, and I believe that comes to 370. So we get 370 equals x squared. So now remember, to undo the square, we need to take the square root of both sides. Now to do that on the calculator, the square root is right here, right above the x squared. So I need to hit second, and then this button. That'll bring me the square root bar. So then type in 370, and we get 19.2, again, rounding everything to the nearest tenth. So 19.2. All right, so if we know any two sides of a right triangle, we can find the third using Pythagorean theorem. All right, and remember, A and B are always the two legs, and C is always the hypotenuse. So in some cases, we may be given C, and we have to find either A or B. All right, so let's try a story problem with the Pythagorean theorem. Okay, so again, A squared plus B squared equals C squared. So this one says an Olympic-sized swimming pool is approximately 50 meters by 25 meters. So a swimming pool is a rectangle, right? So it says it's 50 by 25. But what we want to find is the distance if a swimmer swims from one corner to the opposite corner. So we want to find that distance. Well, what we actually have created here is a right triangle. Right? So we know in a rectangle opposite sides are the same. So these two sides would be 50. We know this is a right angle. Then we want to find this side. Right? So in this right triangle, these are my A and B because these two sides are the ones that create the right angle. And then this would be the hypotenuse because it's opposite the right angle. So my setup, if I'm doing A squared plus B squared equals C squared, would look like this. So then go ahead and square both of these. So 25 squared is 625. 50 squared is 2500. Add these together, and that'll be 3125. And take the square root then of 3125. So second here, 3125 is 55.9. So after I take my square root, we can see that a swimmer would swim 55.9 meters. Right? So whenever we know two sides of a right triangle, we can always find the third. Then we got into trigonometry. Okay, so for sine, cosine, and tangent, remember so, ka, to. Right? So means that sine is opposite over hypotenuse. Ka means that cosine is adjacent over hypotenuse. And toa means that tangent is equal to opposite over adjacent. So, to write out those ratios in a triangle like this, we actually first need to find the missing side. Right? So, if we call this x, then we're going to use Pythagorean theorem yet again. So, my two legs, A and B, and then the hypotenuse is C. So, yet again, in this example, we're solving for the hypotenuse. Right? So, if I'm doing a squared plus b squared equals c squared, I will have 16 squared plus 30 squared equals x squared. So then go ahead and square these. 16 squared is 256. 30 squared is 900. Add these together, that'll be 1156. And take the square root. So the square root of 1156 is exactly 34. Don't have to round. So this missing side here, I can get rid of this x, and I know that this is just 34. So now we want the sine, cosine, and tangent of each of our missing angles. Let's start with Q. Okay, so I want to label this triangle with respect to Q first. All right, so with respect to Q, this 30 would be the opposite side because it's not touching angle Q. 34 would be the hypotenuse because it's opposite the right angle. That leaves 16 would be adjacent because it is touching this angle. It's the leg that's touching this angle. So now sine is opposite over hypotenuse. So that's going to be 30 over 34. Now, we do want to reduce as far as we can. So both of these are divisible by 2. That would reduce to 15 over 17. Cosine is adjacent over hypotenuse, so that'll be 16 over 34. And again, reduce, both of these are divisible by 2, so that'll be 8 over 17. And tangent is opposite over adjacent, so 30 over 16. And again, that will reduce to 15 over 8. So now, if I want the sine, cosine, and tangent of r, I need to relabel. So I'm gonna erase these labels that I have here. And now with respect to r, let's label the sides. So with respect to r, 16 would be the opposite side. 30 would be the adjacent leg, and 34 is still the hypotenuse. So now, sine of r, opposite over hypotenuse, is 16 over 34, which reduces to 8 over 17. Cosine of r is adjacent over hypotenuse, so 30 over 34, which reduces to 15 over 17. And tangent of r, opposite over adjacent, is 16 over 30, which reduces to 8 over 15. So now we used trigonometry to solve for missing sides and missing angles. Right? First, we did missing sides. Okay, and we have done a lot of examples like this. And so remember, so ka toa. So the first step is label the sides. So with respect to this 54-degree angle, this x is opposite, and the 9 is the adjacent leg. So the trig function that deals with opposite and adjacent is tangent. So my setup is going to be tangent of my angle equals opposite over adjacent. So equals x over 9. Then the final step, to solve for x, I'm just going to multiply both sides by 9. These 9's cancel, and I can put 9 times the tangent of 54 into the calculator. All right, so 9 times the tangent of 54 gets me 12 points, and since this is 5 or greater, this would round up to 12.4. So I get that my missing side is 12.4. All right. Then we also solved for missing angles. All right. So again, so ka toa. The process to solve for a missing angle is almost the same. First thing we want to do is, with respect to this angle, label the sides. So with respect to this angle, 23 would be the opposite side, and 24 would be the hypotenuse, since it is opposite of the right angle. So the trig function that deals with opposite and hypotenuse is sine. So my setup is going to be, my setup is going to be sine of my angle equals opposite over hypotenuse. So now remember, whenever we're solving for an angle, that angle is trapped inside the trig function. We need to use inverse trig to get it out. So I'm going to take the inverse sine of both sides. These cancel, and we are just left with x equals the inverse sine of 23 over 24, and that we will put into the calculator. So second sine of 23 over 24, and that will be 73.4. So my missing angle is 73.4 degrees. All right. Now, what about something like this? On this one, we actually want to solve for both missing sides. All right, well, to do that, we can kind of just set up two separate problems. All right. Again, we're going to use so ka toa. So let's first solve for x. So I'm going to completely ignore the y here. I'm going to pretend that's not even there. So with respect to this 30-degree angle, I'm going to label opposite, and 42 would be adjacent. So I'm going to use tangent, because tangent is opposite over adjacent. My first setup here will be tangent of 30 degrees equals x over 42. Multiply both sides by 42. And we'll put 42 times the tangent of 30 into the calculator. 42 times tangent of 30. we get 24.2 if we round to the nearest tenth. So there's our answer for x. So now, to solve for y, I'm just going to do this problem again, but this time I'm going to completely ignore x. So I'm just kind of starting over now. So with respect to this 30-degree angle, the y is the hypotenuse because it is opposite the right angle. 42 then is the adjacent side. So the trig function that deals with adjacent and hypotenuse is cosine. So my setup here would be cosine of 30 degrees equals adjacent over hypotenuse. So this will be equals 42 over y. So to solve for y, we need to multiply both sides by y, and then we will end up dividing by the cosine of 30. So these cancel, and we'll put 42 divided by the cosine of 30 into the calculator. And we get 48 points. If we round this to the nearest tenth, this would round to 48.5. All right. So my hypotenuse would be 48.5. All right. Now, the final thing that we're going to look at in this review is a couple of story problems. So in this, let's start by drawing a right triangle. I know that this is going to be able to be modeled with a right triangle. So it says, the town park does an outdoor movie night every Saturday. Kate is sitting 36 feet from the base of the screen. So if Kate's here and the screen is here, she is sitting 36 feet away. The angle of elevation from Kate to the top of the screen is 24 degrees. And we want to find how tall the movie screen is. So this is the screen. The height would be my variable. So just like we've been doing, we want to label the sides. So with respect to this 24-degree angle, x would be the opposite side, 36 would be the adjacent side. So if we're thinking, so katoa, opposite and adjacent is tangent. So my setup is going to be tangent of 24 degrees equals opposite over adjacent. And then to solve for x, all I need to do is multiply both sides by 36. These will cancel. And I will put 36 times the tangent of 24 into the calculator. And we get that the movie screen has a height of 16.0 feet. All right, let's do one more. So here it says find the angle of depression from the top of a lighthouse 275 feet above water to a boat that is 1,324 feet offshore. So let's draw our triangle here. So my lighthouse is right here. So it says the lighthouse is 275 feet above water. So it has a height of 275. And the boat is 1,324 feet offshore. Right, so here's the lighthouse. The boat is way out here. And I want to find the angle of depression. So remember, angle of depression looks something like this. Right? It's like if we're at the top of the lighthouse, looking down, that's the angle of depression. But remember, this angle and this angle would be the same. Okay, so I can put my x here inside of my right triangle to solve for this angle, the angle of depression. So I need to label the sides with respect to this angle. This would be opposite. This would be adjacent. So yet again, we're going to use tangent because tangent is opposite over adjacent. So my setup will be tangent of the angle. So tangent of x equals opposite over adjacent. So to get x by itself, to get it outside of the tangent function, I need to take the inverse tangent of both sides. So these cancel, and we are just left with x equals inverse tangent of 275 divided by 1324. And that I can put into the calculator. So second tangent, 275 divided by 1324, and we get 11.7. So that angle is 11.7 degrees, all right, which means the angle of depression up here is 11.7 degrees. All right, so remember, your assignment for today is to upload a picture of the notes that you took from this review, and then the assignment for Thursday and Friday, we're going to take 2 days to do this because it's a little bit longer, is an edge elastic that's just a review of all of this material. Okay? As always, send me any questions that you have.